Hello everyone, welcome back to BW Learning. This is Dr. White here. This week, we will be looking at a chemistry topic which is on the solubility of salts. In this topic, we will first look at the classification of soluble and insoluble salts. We will then move on to separate videos where we look at how to go about forming insoluble and soluble salts. Salts, as an introduction, are ionic compounds, and ionic compounds are compounds that contain a positive ion, which we call a cation, and a negative ion, which is an anion. And in the salt formation process, we need to be familiar with the different possible reactions to form a salt. So here are some of the common reactions, and these are the reactions that we need to know to form soluble and insoluble salts. So the first one here would be the reaction between an acid and a metal. And to be even more specific, it should usually be a reactive metal, and this would give us salt and hydrogen gas. The next reaction is between an acid and a base, and this is what we also term as a neutralization reaction. The products here would also be salt, and in this case, water. For the next reaction, it's between an acid and an alkali. The difference between an alkali and a base is that an alkali is the soluble version of a base. So when you react a base with water, if it is soluble in the water, it will form an alkali. Here, similarly, we term this as a neutralization reaction, and we form salt and water. And the final reaction that we look at here, it's between an acid and a carbonate. In this case, we also form a salt together with water and carbon dioxide gas. Here in this slide, we have a table to classify the common soluble and insoluble salts. Most of the time, students are required to memorize them, so make sure you know this classification. In the first row, we have the soluble salts, which are the sodium, potassium, ammonium, and nitrate salts. We have an acronym called SPAN to help students remember them. For these four salts, it is important to note that there are no exceptions, and all of the SPAN salts are soluble. There are no insoluble salts associated with them. In the next row, we have all chlorides, bromides, and iodide salts being soluble. Here, we have a few exceptions, and they would be silver chloride, which is a white precipitate, silver bromide, which is a cream precipitate, and silver iodide, which is a yellow precipitate. We also have lead-2 chloride, lead-2 bromide, and lead-2 iodide, being the insoluble salts. Moving on to the sulfates, most of them are soluble. Again, we have a few exceptions. The first one would be barium sulfate, which is a white precipitate. We also have lead-2 sulfate and calcium sulfate, which is sparingly soluble. So calcium sulfate is soluble in water, but to a very low extent, and it reacts very slowly. So therefore, we tend to classify calcium sulfate as an insoluble salt. For the carbonates, most of the carbonates are insoluble, with the exception of spa salts. And these would include sodium carbonate, potassium carbonate, and ammonium carbonate. All the hydroxides are insoluble, again with the exception of group 1 hydroxides, including sodium and potassium hydroxides. Also, calcium and magnesium hydroxides, they are sparingly soluble. Finally, we have phosphates, where most of them are insoluble salts, except for group 1's phosphates and ammonium phosphate. So now that we are familiar with the classification of soluble and insoluble salts, the next question would be, which method do we use for salt preparation? Here in this slide, we have a mind map, and if we follow through the steps, we would be able to decide an appropriate method for salt formation. So first, choosing a salt preparation method. The first question to ask would be, is the salt to be prepared a soluble salt or an insoluble salt? If it is a soluble salt according to the table that we see in the previous slide, the next question would be, are both the reactants soluble in water? If they are not, meaning if one of the reactant is in the solid state while the other is in the aqueous state, then we use the first method where we react an acid with an insoluble substance. Here, it could be an acid with metal, an acid with an insoluble base, or an acid with an insoluble carbonate. And in this video, we will be going through method 1 for salt preparation. In the subsequent video, part 2, we will then look at the two other methods, which you will see in this slide. So moving on, if both the reactants are soluble in water, we would then use method 2, which is titration. Here we react an acid with an alkali or an acid with a soluble carbonate. Finally, if we are looking at the formation of an insoluble salt, we then use method 3, which we call it precipitation. In precipitation method, we choose two soluble salts as the starting reagents, and these two soluble salts should contain the cation and anion of interest to form the insoluble salt. Now, we will have a closer look at the first method, which involves the formation of a soluble salt using an acid with a metal, or an acid with an insoluble base, or an acid with an insoluble carbonate. Here, we use iron 2 nitrate as an example. So we see that iron 2 nitrate is a soluble salt according to the classification table that we see just now, because all nitrate salts are soluble salts. Then the next question to ask ourselves is whether this salt can be prepared by an insoluble base, carbonate, or metal. So we know that iron is able to react with nitric acid to form iron 2 nitrate and hydrogen gas. So therefore, in terms of steps, the first step would be to react the iron powder with the nitric acid. Here, you want to react excess iron with the nitric acid, because the salt that will be formed subsequently, which is iron 2 nitrate, is a soluble salt. If the acid has not been fully used up, you would then contaminate the soluble salt that we have. This is why we need to add iron powder until no more iron powder dissolves. This is where we know that all the acid has been used up. Another way to tell that all of the acid has been used up is that no effervescence is further observed. In this case, we see that hydrogen is released as a gas as we add iron powder to nitric acid, when all the acid has been used up, hydrogen gas will not be involved, and this is where we can be sure that we're only left with the iron 2 nitrate that is formed. Subsequently, in the second step, because we want to obtain the salt which is iron 2 nitrate, we therefore carry out filtration, where we would filter away the excess iron and collect the excess iron as a residue. The iron 2 nitrate, which is a soluble salt, would pass through the filter paper and be collected as the filtrate. So this filtrate is our soluble salt that we would eventually want to collect. In the third step, with the filtrate that we have obtained, which is a pure solution of iron 2 nitrate, we then carry out crystallization. Here, what we do is we heat the solution until we obtain a hot saturated solution. These will help the crystals to crystallize. How do we know that we have attained a hot saturated solution? One simple way is to dip a cold glass rod into the solution and take it out from the solution. If you observe crystals appearing on the glass rod, we know that a hot saturated solution has been obtained. After which, you can allow the solution to cool and iron 2 nitrate crystals will start to appear. Finally, to obtain the pure iron 2 nitrate crystals, we can filter to collect the crystals and subsequently wash the crystals with distilled water to remove any impurities that may be present on the surface. Finally, we dry them between sheets of filter paper. Now that we have looked at the procedures related to the formation of soluble salts using the first method, then we should know also when to or when not to use this method. This method is suitable for the formation of soluble salt, but more importantly, it is suitable when moderately reactive metals such as zinc, iron, and magnesium are present in the salt of interest. So method 1 would be suitable for salts such as zinc sulfate, iron 2 nitrate, and magnesium nitrate. However, this method is not suitable if we are forming salts that contain reactive metal, and examples would be sodium sulfate, potassium nitrate, basically group 1 metal salts. This is because in this method 1 of salt preparation, we actually react the metal with the acid as one of the options. So group 1 metals being very reactive, they would have a violent reaction with the acid, and this will be very dangerous. Instead, in the subsequent video, we will see that the titration method is a much more suitable method for the formation of these type of salts. Method 1 is also not suitable for very unreactive metals such as copper salts and silver salts. This is because these metals, being very unreactive in nature, they do not react with dilute acids. And this would include copper 2 nitrate salts and the formation of silver sulfate salt. If we really want to use method 1 to form these salts, very often we have to use hot and concentrated acids instead. One point to note here is that In the case of copper, for instance, if we want to form copper 2 nitrate, we could, instead of using copper metal, use copper 2 oxide with nitric acid. And this would give us copper 2 nitrate. So we have come to the end of this video. I hope you have learned something useful. If you enjoy watching our videos, please hit the like and subscribe button. If you have any ideas in comments or questions, please comment in the comment box below, and we will see you in the next video. Thank you.